Good morning friends, welcome back to Panika Tutorials. In this video, I want to discuss about round robin scheduling algorithm, which is one of the important and confusing scheduling algorithm. So I request everyone to watch the complete video for better understanding. For any scheduling algorithm, we will have two important parameters. One is the criteria. The criteria can be arrival time, burst time, or time quantum, or even the priority also. If it is first come first serve scheduling algorithm, the arrival time is the criteria. If it is shortest job first and shortest remaining time for scheduling algorithm, the burst time is the criteria. For a round robin scheduling algorithm, the time quantum is the criteria. Coming to the mode, we will have two modes of scheduling algorithms. One is preemptive and another one is non-preemptive scheduling algorithm. Let me give an overview about the non-preemptive and preemptive scheduling algorithm. Then I will discuss about the round-robin scheduling algorithm with an example. Coming to the non-preemptive scheduling algorithm, if any processor has been entered into the running state from the ready state, if it does not require any IO operations, then it will complete its task and will go to the terminated state. Whereas in the preemptive scheduling algorithm, if a processor has entered into the running state based on the criteria, if it is a burst time is the criteria, if any processor which is there in the running state, it has the higher burst time as compared to the processor which is there in the ready state, then we will remove the processor from the running state and will kept in the ready state. The processor which is having the less burst time in the ready state will be kept in the running state. If the time quantum is the criteria, after a particular amount of time, suppose let's take the time quantum is 2 units. In this example, I have considered the time quantum is 2 units. Suppose let's take the processor P1 has been arrived at 0 units of time and it has been entered into the running state. It needs totally 5 units of service time or the burst time of the CPU to complete its task. But however, if you have specified the time quantum is 2 units, it will be run only for 2 units. Then it will be preempted from the running state and will be kept in the ready state. If any processor is there in the ready state, that will be shifted to the running state. Is it clear? Suppose you can ask me one thing. Sir, let's take that there is a one processor P4, its burst time is only 1 unit. If its burst time is 1 unit, will we run it for 2 units? No. If it is only 1 unit, it will be executed for 1 unit and it will be shifted to the terminated state. Is it clear? So with this introduction, let me solve this numerical question to make you understand the round robin scheduling algorithm. To solve the round robin scheduling algorithm, we need to consider the two queues. One is the ready queue and running queue. Okay, even we will take the Gantt chart. Okay, the Gantt chart will start from 0 units of time. Okay, look at here. At 0 units of time, how many processors have been arrived into the ready state? Only one processor, which is P0, has been arrived into the ready state. So P1 processor is there. If only one processor is there, that will be in the running state. Is it clear? So how much time it will be running? Its burst time is 5 units. However, the time quantum is given 2 units. So the processor P1 will be run for 2 units of time. Is it clear? By that time, if you look at, two processors have been arrived, such as P2 and P3 have been arrived at 1 unit of time and 2 units of time. So both of them arrived. So P2 has been arrived, then P3 has been arrived. Is it clear? Currently P1 was running for 2 units of time. Once its time quantum is completed, it will be removed and will be kept in the ready queue again. Is it clear? Please remember again. The processor P1 was initially arrived and it was kept in the running queue and it has executed for 2 units of time because the time quantum is only 2 units. By that time, processor P2 and processor P3 has been arrived. Which processor has been arrived first? P2. So that's why I have kept P2, then P3. As the time quantum of P1 processor has been completed from the running queue, it will be kept in the ready queue. So this is done. Then what is the meaning? You have to run P2, then P3, then P1. That is the meaning. So P2 will keep it. The remaining time for the P1 is 3 units. Now P2 burst time is 4 units. It will be kept in the running queue. So from 2 units to 4 units, we will run the processor P2. By the time processor P4 has been arrived to the ready state, as its time quantum is completed, we will remove the processor P2 from the running queue and will be kept in the ready queue. So this one is completed. Are you able to understand it or not? Now you need to run the processor P3, so it will be kept in the running queue. And how many units of time we have to run? This one left is 2 units. This burst time is 2 units, so it will run for 2 units of time. So its remaining burst time will become 0. Are you able to understand? So it is completed. Once it is completed, it will go to the terminated state. By the time any new process have been came, no other process, so it will be removed from the running queue. Should I keep it in the ready queue? No, its task is been completed, so it will be gone to the terminated. Is it clear? So the P3 is done. Now P1 is there, we will keep it in the running queue. Okay, now how many units of time we will run it? For 2 units of time, because it needs 3 units of time, but however time quantum is specified as 2 units of time, so P1 will run for another 2 units of time, so its remaining burst time is only 1 unit. Okay, by the time no other process came, so we will keep again the processor P1 from the running queue to the ready queue. This one is completed. Now P4 will be kept in the running queue because it is next one, so we will keep it in the running queue, and the processor P4 needs 2 units of time and even time quantum is 2 units of time, so we will run for processor P4 for 2 units of time. Its remaining burst time is 0, so it will be shifted to the terminated state. So it will be removed and it will be kept in the terminated state, so we no need to keep it in the ready queue. So processor P4 is also done. Is it clear? Are you able to understand? So what are the other process? Processor P2 and processor P1 is in the ready queue. Which one is in first? P2. So P2 will be kept in the running queue. And how much burst time it requires? It requires 2 units of time. So P2 will be run for 2 units of time because time quantum is also 2 units. So it will be run for 2 units. As it needs only 2 units, its remaining burst time is 0. So it has completed its task. So it will be removed from the running queue and will be kept in the terminated state. So even processor P2 has completed its task. Now processor P1 has been left, which is in the ready queue. We will bring it into the running queue. We will execute for only 1 unit of time because its burst time is only 1 unit. If its burst time is only 1 unit, why should we run it for 2 units of time? Is it clear? So we will run it for only 1 unit of time. So this is the Gantt chart for the given question for the round robin scheduling algorithm. Now using this Gantt chart, we will find the completion time, turnaround time, waiting time and response time for each processor. Okay. First, let me find the completion time of each processor. The completion time meaning is that at what time the processor has been completed its task and went to the ready terminated state. Processor P1 has completed at 13 units of time. Processor P2 has completed its task at 12 units of time. Processor P4 has completed its task at 10 units of time. Processor P3 has completed its task at 6 units of time. Is it clear? Are you able to understand it or not? Now we need to compute the turnaround time. Turnaround time is equal to completion time minus arrival time. Okay, so the completion time of processor P1 is 13 and it has arrived at 0 units of time. So 13 minus 0 is 13, 12 minus 1 is 11, 6 minus 2 is 4, 10 minus 4 is 6. Then we will compute the waiting time of each processor. The waiting time is equal to turnaround time minus burst time. Look at the processor P1 turnaround time and burst time. which is 13 and 5. So 13 minus 5 is 8. 11 minus 4 is 7. 4 minus 2 is 2. 6 minus 2 is 4. Are you able to understand it or not? Now we need to compute the response time. Okay. If it is a non-preemptive scheduling algorithm, the waiting time will be equal to the response time. But however, the round robin is a preemptive scheduling algorithm, the response time may vary with the waiting time. What is meant by response time? The difference between the processor when it has entered the first time in the running state and the arrival time. Look at the processor P1 when it has first time entered into the running state at 0 units of time. And what is the arrival time of processor P1? 0. So 0 minus 0 is 0. Similarly, processor P2, when it has first time entered into the running state at 2 units of time, first time it entered into the running state. And what is its arrival time? 1. So 2 minus 1 is 1. Similarly, processor P3, at 4 units of time it has entered the running queue first time and its arrival time is 2. So 4 minus 2 is 2. Processor P4, 8 minus 4 is 4. Is it clear? Are you able to understand it or not? So if you look at the waiting time and response time of processor P1 and P2 is different, but however processor P3 and P4 is same. But overall it is not same. I hope it is clear for you. Once we compute the completion time, turnaround time, waiting time and response time, in any competitive exams, they will ask you average turnaround time and average waiting time. Let me discuss how can you compute the average turnaround time. The average turnaround time is nothing but sum of all the process turnaround time by number of processes. Look at here, 13 plus 1, 11 plus 4 plus 6 by 4, which is nothing but 24, 28, 34 by 4. So 34 by 4 is the average turnaround time. Similarly, let me compute the average waiting time. Average waiting time is sum of all the process waiting time by number of process, which is 8 plus 7 plus 2 plus 4 by 4, which is 15 plus 6 is 21 by 4. So this is the average waiting time and average turnaround time for the given question for a time quantum of 2 for a round robin scheduling algorithm. I hope you have understood round robin scheduling algorithm. If you have any doubts related to the round robin scheduling algorithm, feel free to ask me in the comment section. I will try to clear your doubts as early as possible. In the next video, I will take few gate questions related to the round robin scheduling algorithm and solve it for you. Thank you for watching the complete video. Have a nice day.